Hi everyone, in this video we will see how VXLAN is configured from scratch, okay, and how packet forwarding works in VXLAN. I will be using Arista switches. However, it's a standard concept and it works the same way for any other vendor like Cisco, Juniper, etc. It will be just a matter of syntax. We will use this simple topology. We want server 1 and server 2 to be able to talk to each other. Please note that server 1 and server 2 belong to the same subnet, okay, which means this is a switching example. In VXLAN terminology, we call it VXLAN Bridging. If you understand how VXLAN Bridging works, it will be very easy to understand how VXLAN routing works, okay? I will demonstrate VXLAN routing in the upcoming videos. Now, coming back to our demonstration, as a refresher, first I will build this simple topology with plain VLAN, okay, and see how the packet forwarding works. So you could relate it to the packet forwarding in VXLAN. Now, some of you might be wondering why I am using this simple topology. There is no MLAG, there are only two leaf switches, etc. Well, there is a reason behind that. My philosophy is to always start simple, because once you understand a concept in the simplest way, it becomes really easy to apply it to bigger topologies. Okay, now let's move on. Now here I am displaying the same topology differently to help you visualize it. Now let's configure our devices with only VLANs end to end, okay? So here you can see that on all the switches we will configure the VLAN 10, and then we will pass the VLAN on all the required ports. And on server 1 and server 2, we will also create the interface VLAN 10 and we will assign the IP addresses. Okay, so let's jump onto the CLI. Now let's go back to our topology. Now within each switch, that's how the VLAN 10 looks like. Let's verify. So in CLIF 1, you can see show VLAN ID 10, and you can see that we have the VLAN configured on the required ports. If I want to look at it on all the switches, so I can just do show VLAN ID 10, and you can see that the VLAN is configured on all the required ports. Now let's look at the MAC table in each device. You can see that the MAC table is empty. We have no MAC entries yet. Now let's generate a ping from server 1 to server 2 and see if it works. The ping worked. Now let's do a packet walk to see how the ping worked. As soon as you hit the ping command on server 1 switch, the server 1 switch finds out that it does not have a MAC entry for the server 2. So it does not know how to reach server 2. No port information, no MAC address information. So before sending out the ICMP ping packet, it needs to resolve the MAC address for server 2. So for that, it will use an ARP request. Okay, so server 1 will create an ARP request, source MAC of the interface VLAN 10. Okay, the source IP of the interface VLAN 10. Okay, and the destination MAC is unknown. Okay, and the destination IP is 172.16.10.2. So it will encapsulate this ARP request in the VLAN tag. Okay, now please note that I use the word encapsulate. Okay, so actually VLAN tagging is a kind of encapsulation. It helps switches identify which virtual network the frame belongs to, right? Please take note of this. We will use similar kind of concept in VXLAN. Okay, and then finally it will add the source MAC is again the VLAN 10 and the destination MAC is FFFF. Why? Because the destination MAC in the ARP request is unknown. So this unknown destination MAC is represented as a broadcast MAC address in the Ethernet header. So what it will do is the server 1 then broadcasts this frame out all ports where the VLAN 10 is configured. So we have configured the VLAN 10 only on Ethernet 1. So it will send this frame out Ethernet 1. Now, when this frame reaches CLIF 1, first of all, because it's the first time it received a frame from server 1 in the VLAN 10, it will update the MAC table. Okay, with the port information. So it will update the MAC table with this source IP, with this source MAC and the port number. Okay, and then it will forward the same frame out Ethernet 1. And similarly, spine switch and the bleaf switch, they will update the MAC table and they will forward this frame out all the ports except the port where they received this frame on. Okay, now finally the frame reaches server 2. Now server 2 has an IP address configured on the VLAN 10, so it has to check the ARP request. So when it checks the ARP request, it finds out that this ARP request is destined to server 2. So now it has to send an ARP reply. And please note that the server 2 will also update the MAC table based on this source MAC. So now it knows how to reach server 1. So it will send an ARP reply, okay, following the same process. So, but this time the ARP reply is being sent to server 1, okay. It will encapsulate the ARP reply in the VLAN tag, okay. And then finally the Ethernet header, and similarly all these switches, when they receive the ARP reply, they will update their MAC tables with the MAC address of server 2, okay. And finally when the server 1 receives this ARP reply, now it knows the MAC address of server 2, okay. And now it can send an ICMP ping packet to server 2. So this is the ICMP ping packet, okay. And again it will encapsulate the ping packet in the VLAN 10 and it will send out to server 2. So all of the switches like CLIF 1, spine 1, bleaf 1, they will just look at the destination MAC address and they will forward the packets to server 2. And when the server 2 receives the ICMP echo request, it will send the echo reply, okay. And let's have a look at the MAC tables on CLIF 1. Show MAC address table, okay. The MAC entry is expired, so let me send the ping again. now you can see the MAC addresses. Okay, this is the MAC address of server 1 and this is the MAC address of server 2. Okay, so now let's build this same topology with VXLAN. Now here, first of all, let's remove all the configuration from our switches, and we will build our switches for VXLAN from scratch. Okay, so let me come here and I will just roll back, and you can see show VLAN ID 10, it's no more there. So all the switches are now blank. Okay, now let's move on to build the same topology with VXLAN. Now, first of all, what is VXLAN? VXLAN facilitates the extension of layer 2 networks. These are layer 2 networks over layer 3 infrastructure. Okay, and this infrastructure is going to be now layer 3. Okay, if you look at this line, I have highlighted some words. If you understand these words, you understand VXLAN. Okay, these words are actually steps. Okay, so in step 1, we will build the layer 3 infrastructure. Okay, and what is that? So first of all, we will assign IP addresses on the interfaces between leaves and spine. Okay, and we will configure OSPF on that. Okay, then only on the leaf switches we will create loopback addresses, and we will advertise the loopback addresses into the OSPF. So it's step 1. In step 2, we will build layer 2 between leaf switches and the server. Simple. In this step, we will configure the VLAN 10 and we will assign it onto the ports. Okay, here between leaf switches and the servers. Okay. In the third step, we will see how to configure the VXLAN. Okay, so now in this slide, we will just do step 1 and step 2. The next step I will show you in the next slide. So now let's jump onto the CLI. So here, if you look, this configuration is for step 1, where we will configure the interfaces with the IP addresses and we will advertise those interfaces into OSPF. Please note that now the leaf switches and the spine switch, now as they have to participate in OSPF routing, so we need to put this command. Okay, so now first let's configure cleaf1, Control C, the bleaf1 and the spine 1. Now step 2, let's configure the VLAN 10 between the servers and the leaf switches. Server 1, server 2, and now the VLAN and the ports on the leaf switches. Now step 1 and step 2 are complete. Let's go back to our topology. So now let's verify if we have the OSPF in full state. So show IP route. show IP OSPF neighbor, and you can see that with the spine, my OSPF neighborship with CLEAF1 and the BLEAF1 is in full state, and we can see show IP route. We can see that we receive the BLEAF1 loopback IP via OSPF, and similarly here if you see we have CLEAF1 loopback IP via OSPF. Okay, now let's look at the layer 2. Okay, now here on the CLEAF1, show VLAN ID 10. Okay, so now you can see here the VLAN ID is just on the Ethernet 5. You see here between server 1 and the CLEAF1, and similarly if we look at the show VLAN ID 10 on the BLEAF, it's just Ethernet 5. Now suppose if I send a packet from server 1 to server 2, do you think that the packet can reach server 2? No, it cannot reach. Why? Because the layer 2 is broken. Okay, CLEAF1 has no idea how to forward a packet towards server 2 if it receives the packet in VLAN 10, because we have just one interface in the VLAN 10. So we need a way to extend this layer 2 network over layer 3 infrastructure. Okay, or we need some way to join these networks together. So here VXLAN comes into the picture. Okay, now in this final step, what we will do is we will create VXLAN interfaces on the leaf switches CLEAF1 and the BLEAF1. Now what is a VXLAN interface? VXLAN is also called a VXLAN tunnel interface. Please don't get confused with the word tunnel. Okay, it's not a persistent stateful connection. Okay, it's just a process of encapsulation and decapsulation. When we say encapsulation, means adding some new headers, and decapsulation means removing the headers. Now inside the VXLAN interface, we will map the VLAN 10 with a new identifier. We call it VXLAN network identifier. Okay, and we will define this identifier inside the VXLAN interfaces. Okay, now when the packet comes from server 1, okay, inside the VLAN 10, it reaches CLEAF1. CLEAF1 will remove the VLAN tag. Okay, it will encapsulate the packet with some new headers. Okay, it will put the VXLAN ID into the header. Okay, and it will send the packet to the BLEAF1. Okay, when packet reaches the BLEAF1 switch, okay, BLEAF1 switch will remove the headers, means it will decapsulate the VXLAN packet, and it will forward the packet to server 2 in the VLAN 10. Now let's look at the configuration of this final step. So here now, okay, here I will just give you a brief introduction of each command. I will explain all of these commands in detail when we do the packet walk. Now here you can see that in the leaf switches, first of all, we will define the VXLAN interfaces. Okay, now this command, VXLAN source interface loopback 0, this command is just telling the switch that for any VXLAN encapsulated packet, use the source IP in the header as the loopback 0 IP address. Okay, And then here we are telling the switch that map the VLAN ID 10 to a new identifier 10,000. It's just a random value. You have almost 16 million values to choose from. Okay, now this command, the final command, this is very important to understand. This is just saying that if you receive a BUM packet, BUM means broadcast, unknown unicast, or the multicast packet in the VLAN 10, send this packet to the remote leaf switch, which is bleaf 1 in this case. And similarly on the bleaf 1, we say that if you receive a BUM packet in the VLAN 10, send this to cleaf 1. Okay, now this is a manual way of telling the switch where to send the BUM traffic. Okay, if you want to get rid of this command to automatically send or receive this information, you can use BGP EVPN. Okay, I will make a separate video on that, as I wanted to keep things simple in this video. As we are not using BGP EVPN in this demonstration, so we are manually putting this information. This is called VXLAN flooding. Okay, in Cisco it is called static ingress replication. Okay, now let's jump onto the CLI and configure this final step. Now let's go back to our topology. Now here, now if you see the show VLAN ID on the cleaf 1, show VLAN ID 10, you see here, now we have a new interface in show VLAN ID. Now at least the switch knows, the cleaf switch knows that it has one more interface, which is the VXLAN interface in the VLAN 10. Now let's look how the VXLAN interface looks like. So on the cleaf 1, let me do show interfaces VXLAN 1. So you can see here the VLAN 10 is mapped to a new identifier, the VXLAN network identifier. And what's this? Hidden replication flood VTEP list. This means the broadcast traffic in the VLAN 10 should be sent to this remote leaf switch. Now similarly on the bleaf 1, show interfaces VXLAN 1, you can see that we have the mapping and the remote leaf switch information for the BUM traffic. Okay, now let's do first of all, let's see if we have anything in the MAC table. Okay, show MAC address table. The MAC address table is empty. Initiate a ping from server 1 to server 2 and see if the ping works. So ping 172.16.2, 172.16.10.2. The ping worked. Okay, now let's look at the MAC table on the leaf switches. Show MAC address table. You see here, this MAC belongs to server 2 and we receive it via the VXLAN interface. And now look at the VXLAN address table. You see here the VLAN 10. In the VLAN 10, we receive this MAC from this remote leaf switch. Okay, and similarly on the bleaf switch, show MAC address table. Okay, and show VXLAN address table. Now let's do a packet walk to see how the ping worked. Okay. Now here, as soon as you hit the ping command on server 1, okay, server 1 has no idea where the server 2 resides, so it will send an ARP request in the VLAN 10, and the request is FFFF, means it's a broadcast packet. Guys, this is very important. Okay, now this packet reaches CLEAF 1. CLEAF 1 looks at the destination MAC address, okay, and it finds out that CLEAF 1, it finds out that it has the VLAN ID defined on two interfaces. So as it's a broadcast packet, so it needs to send the packet out on all the ports where the VLAN 10 is configured, except the port where it received the packet on. So it will not send the packet here. So it has to send the packet on the VXLAN 1. So as soon as it finds out it has to send the packet on the VXLAN 1, it will remove the VLAN tag. You can see here, this field is there and the Ethernet tag is there. So it will add a new header, okay, the VXLAN header with the VNI 10,000. Now where does this value come from? So show run interface VXLAN 1. We put this value that the VLAN 10 is mapped to 10,000. So it's a new header for the VXLAN, because at the remote end, when the packet will be received by the belief 1, it needs to identify which virtual network the packet belongs to. So it needs to have some kind of identifier. So after that, it will add the UDP header. Now why the UDP header? VXLAN uses UDP encapsulation, so it has to add a UDP header. Now where these entries come from? The source port and the destination port. The source port is a random number and the destination port is the default UDP port used for the VXLAN. It comes from here, you see here. So this command comes by default 4789. Now after that, it will put an IP header. Now why an IP header? Because VXLAN is designed to operate over IP. Okay, so and now where do these entries come from? The source IP and the destination IP. The source IP comes from here, because we have explicitly told the switch that any VXLAN encapsulated packet should use the source IP as loopback 0. So if I look at the loopback IP 0, it's this IP 172.16.01. 172.16.01. Now where does that destination IP come from? It comes from this command. Any broadcast traffic in the VLAN 10 should be forwarded to this IP address. So it comes from there. Now CLEAF 1 has to put one final header, which is the Ethernet header. This is used to forward the traffic to next hop. So if we look at the next hop, show IP route for the destination IP 172.16.02, it is via Ethernet 1. So it will put the MAC address of Ethernet 1, CLEAF 1, and the destination MAC is the spine 1 Ethernet 1 interface. So it will forward this packet to spine 1. Now spine 1 will just look at the destination IP of this packet and it will just perform the routing. So if you look at here, show IP route 172.16.0.2, it knows that it can reach this IP via this next hop. So it will just rewrite the Ethernet header, okay, to send the packet to the next hop, which is the bleaf1. So now when the bleaf1 receives this packet, okay, it finds out that the packet is destined to itself, because the destination IP is 172.16.0.2, which is configured on its loopback interface, and it finds out that the packet is destined to VXLAN, as the destination port is the UDP port for VXLAN. And further, it finds out that the network identifier is 10,000. So we come into the bleaf1, show interfaces VXLAN1, and here it finds out that it received the packet with this VXLAN identifier. So it will remove the headers. It will remove all of these headers, okay. It will put the VLAN tag, okay, and it will send the packet out to server 2. Now, during this whole process, please note that the cleaf1 will record the source MAC in the MAC table, and here the bleaf1 will record the source MAC on both the tables, the MAC address table and the VXLAN address table. So now let's look at here, show MAC address table. Okay, I think the entry is expired, so let me ping again. So here you can see that the MAC address table, it will build the entry, and similarly show VXLAN address table, it will build the entry here that it received the ARP request from 172.16.0.1, and this is the MAC address. Now, one thing note here, that the VLAN tag is not there in the VXLAN packet. It means that you can use different VLAN IDs between the leaf switches and the servers. Now, the identifier is the VXLAN ID. You have to make sure that for each virtual network, you have the same VXLAN ID on all the leaf switches for a particular virtual network. Okay. When server 2 receives the ARP request, it will update the MAC table, and now it has to send an ARP reply. So now when server 2 sends an ARP reply, it knows the destination MAC address, okay, from ARP request, okay, and it will send this packet out to the bleaf1. When the bleaf1 receives the packet in the VLAN 10, it will perform the lookup in the MAC table, show MAC address table. It knows that it has to reach this destination MAC, and it can reach out this MAC address via VXLAN1 interface. And further, it will have a lookup in the VXLAN address table that it has to send the packet to this, which is the cleaf1. So it will remove the VLAN tag, okay, it will put the VXLAN header, the UDP header, and the IP header. Please note that in the IP header now, destination IP is the cleaf1, and it will send the packet out to spine1. When the spine1 receives the packet, spine1 is just there to route the packet between the leaf switches. Okay, so when the spine1 receives this packet, it will perform an IP lookup based on this destination address 172.16.0.1. It will rewrite the Ethernet header, okay, and then it will send this packet out to cleaf1. Now when the cleaf1 receives this packet, okay, it knows that it received the packet on the VXLAN interface because of this UDP header, okay, and then it will switch the packet to the server 1 in the VLAN 10, okay, and here it will update the MAC address table and the VXLAN address table. Okay, similarly here, when the bleaf1 receives the ARP reply, it will also update the MAC address table with the MAC address of server 2. Now all of the switches, they know about the MAC address of server 1 and server 2 except the spine switch, because spine is just there to route between the cleaf1 and the bleaf1 on their loopback IP addresses. Okay, now when the server 1 has the ARP reply, now it can send the ICMP request packet and the ICMP reply packet. Okay, and now they can simply switch the packet based on this information: show MAC address table and show VXLAN address table. Okay, now so when the server 2 receives request, it will send a reply. Okay, now finally, that's how the packet structure looks like. Between the leaf switches, it's the payload, the VLAN tag and the Ethernet header, and between the leaf switches, it will add the VXLAN header, okay, the UDP header and the outer IP header and the outer Ethernet header. Okay, now finally I will just summarize the steps how we configure the VXLAN. Step 1, we will build the IP infrastructure, the layer 3 infrastructure, and step 2, we will build the layer 2 networks between the leaf switches and between the servers and the leaf switches. And in the final step, we will configure the VXLAN interface to extend these layer 2 networks. That's the end of this demo session. Until next time, goodbye.